All right, this is 4-9, and you can go ahead and do the warm up on your own. Just remember your formula is AN equals A1 plus N minus 1 times D. And you can only do it if it's arithmetic, so if it's not arithmetic, don't do it. And plug them in and find the specific term. Today's lesson is all about patterns, and these can be a little bit tricky because there's not necessarily a set way of doing it. It's more so trial and error and see if you can find the pattern. Okay, so sometimes some people get it really quickly and other times it's harder for people. So don't get discouraged if it takes you a little bit longer to find the patterns. It might just take you some time and some practice, and that's okay. But what we're going to do first is look at patterns with pictures, okay? When you are given a bunch of shapes or pictures or whatever, the goal first is going to be to find out how many different ones there are until the pattern begins to repeat, okay? So you need to know how many different ones there are before it starts to repeat. So if I'm looking at these check marks, this one, I'm going to number it number 1 because it's the first one. 2 is different, so I'm going to mark it as 2. 3 is still different. 4 is another rotation. 5 looks exactly like 1, which means we can assume that the pattern is going to start over again, and 5 just looks like 1. So I only numbered the ones that looked different, and then I just restart my number, which means 6 is going to look like 2, 7 will look like 3, and 8 will look like 4, so on and so forth, okay? So you number them, how many different ones you have until it begins to repeat. So we had 4 different ones, okay? So this one asks what the next 2 will look like. Well, 5 we already had looked like number 1, so the following 2 will look like 2 and 3, okay? The tricky part comes if I ask you, what is the, let's say, 22nd shape going to look like? Okay, which one is the 22nd one going to look like? Well, here's the deal. If there are 4 different ones like we have here, we have 4 different shapes, then all of the multiples of 4 are going to land on this last check mark. So 4, 8, 12, 16, 24, 20, 24, all of those, okay? All of your multiples of 4 will land on the last check mark because there are 4 different check marks. If there are 5 different things, then multiples of 5. If there are 6 different things, then we're doing multiples of 6. So however many different patterns there are before it repeats, you're going by multiples of that number. So this is 4 different check marks, so we're going to go by multiples of 4. So you're looking for your closest multiple of 4 to 22. 22 itself is not a multiple of 4, so we know the 22nd check mark will not be the 4th one. 20 is a multiple of 4, so we know that 20 is here on 4. So then you just count up from there. So 21, 22 is going to look like the second one. Okay? And we can do this for a bunch of different numbers. Like I could do, I don't know, 107, okay? So what is the 107th check mark going to look like? Well, 100 is a multiple of 4, and so is 104, and so is 108. So you can kind of go off of those numbers. So let's say I did 108. I know 108 is here because it's a multiple of 4, which makes 107 1 back. So you can go forwards or backwards. You could have done 104 and then count it up. Either way, 107 is going to look like the third check mark. So you're going to go by multiples of however many different ones you have. So let's look at these half circles. First step is to number them with however many you have to begin with. So 1, 2, 3, 4, 5. I see a repeated one now at 6 is open and 7 is red, so it repeats. So 6 and 7 look like this, which means 8, 9, 10, so on and so forth. So now I'm going by multiples of 5 because there are 5 different ones. So before I was going by multiples of 4, and now I'm going by multiples of 5. Okay, however many different ones there are, those are the ones you go by. So 20 says, what will the 20th half circle be? Well, 20 is a multiple of 5, so it's going to be green. So the 20th is going to be green. Okay? If I said 56, okay, what will the 56th one look like? The closest multiple of 5 to 56 would be 55. So 55 will be green, which makes 56 open. Okay? So you go by multiples of however many the last one is. Okay. Go ahead and do this one on your own. What will the 5th and 6th flowers look like? Non-arithmetic sequences. So these are just patterns, just in general. So we did arithmetic sequences when it was a very specific type of pattern. But now we're going to do any kind of pattern, and we just had to figure out what it is. So just find the next 3 numbers. So this one's pretty simple. From 3 to 6 and 6 to 12 and 12 to 24, I am doubling these numbers every time. So my pattern is multiply by 2. Okay, so then you're just going to continue because it asks you to find the next 3. So 24 times 2 is 48. Times 2 gives you 96. And then the last one is 192. And then dot, 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 because it's going to continue. So you just have to find the pattern and then find the next 3 terms, okay? There are 6 of these. Okay, I'm going to do, I'll do 2, okay? So they're not going to necessarily be arithmetic. They're all different kinds of patterns. So 29 to 28, I'm subtracting 1. 28 to 26, I'm subtracting 2. Then I'm subtracting 3, minus 4. So 1, 2, 3, 4. The next one's going to be minus 5. So 19 minus 5 is 14. Subtract 6, right? Because the pattern has to continue, which gives you 8. Subtract 7, which gives you 1, and then it's going to continue. Okay, so minus 4, minus 5, minus 6, minus 7. So the pattern just changes or continues the same way, but it's a different number every time, so it's not arithmetic. The third one just has some variables, so x minus x, x minus 1, x minus 2. The next one after that would be x minus 3, x minus 4, x minus 5. Okay, pretty basic. You just kind of have to look at it and decide what is actually happening and just find the next 3 terms. So go ahead and do 1 and then these 3 as well. Okay? So pause it, do those 4 questions, and then we'll move on. An equation from a graph is a little trickier. What we're going to do to try to help us. First of all, I asked you to make an XY table out of the ordered pairs that we have. So I'm going to identify all of these ordered pairs first. So this point is at negative 3. 1, 2, 3, 4, 5, 6, negative 6. Okay. Oops, negative 5. Sorry. Negative 3, negative 5. This point is at negative 2, negative 3. This point is 0, 1, and 1, 3. Okay, so I have all of the points on that graph that I'm going to use, and I'm going to put them in my XY table. So negative 3, negative 5, negative 2, negative 3, 0, 1, and 1, 3. Okay, so I'm going to use these numbers. The goal is to figure out what is happening to x to give us y. So here are my options. Y equals x can be multiplied by something and x can be added something. So these are the two spots that I'm going to try to fill, okay? I need to figure out a pattern. What is happening to x to get to y that works for all of these points, not just one of them, but all of them. The easiest way I have found to do this is you always start where x is 0, because the only way to get from 0 to 1, in this case, from 0 to 1, you could multiply x, which is 0, by something all day long, and you would still get 0. So the only way I can get from 0 to 1 is by adding 1. So I know that that has to be true. I know my last part has to be plus 1. Okay? After that, I just can work backwards. Okay? So my answer up here is negative 5. So before I added 1 to negative 5, I was at negative 6 because I know the last thing I did was add 1. So I dropped back down to negative 6. And then I ask myself, how am I getting from negative 3 to negative 6 by multiplying? So negative 3 times what gives me negative 6? Negative 3 times 2 gives me negative 6. So let's just show you what this did. So if I'm saying this is my pattern, or this is my equation, 2x plus 1, then I'm saying 2 times my x, which was negative 3, add 1. Okay, 2 times negative 3 is negative 6, plus 1 is negative 5, which is what my y value is. Okay, my goal is to see if that holds true for all of those points. So then I'm going to go to the next one, which is negative 2, and I'm going to see if that works for that. So 2 times negative 2 plus 1. 2 times negative 2 is negative 4, plus 1 is negative 3, which was my y value. So it worked for this point. It worked for this point. The 0 point, it should work because that's where I started from, right? So 2 times 0 plus 1. 2 times 0 is 0, plus 1 is 1, so that one works. And then the last one I'm going to try, just to make sure, 2 times my x, which is 1 plus 1, that's 3, so that also works. So my answer is that equation I wrote, y equals 2x plus 1. And I found it by looking at the ordered pairs and finding a pattern that worked for all of them to get from x to y. All right, let's look at this one. Start by getting the ordered pairs and putting them in the table. 1, 2, 3, 4, 1, 2. So negative 4, negative 2, negative 2, negative 1. We're just taking the ordered pairs and putting them in the chart. 0, 0, 2, 1, and 4, 2. That one needed an extra little box. Okay. Now, I have to find a pattern that works to get from x to y. So remember, I'm going to have y equals x can be multiplied by something and x can be added to something, and those are the two spots that I have to try to fill, these two blanks. Remember, the best place to start is when x is 0. So when x is 0, oh, so was y. So that means I am not adding or subtracting anything. So my last blank is 0. Then the only way I can get from x to y is going to be by multiplying. So how can I get from negative 4 to negative 2? First of all, it's negative and it's staying negative, which means I'm not changing the sign at all. From 4 to 2, I'm multiplying by 1/2, or I'm dividing x by 2. You can do it either way. Okay? So see if that holds true. What's 1/2 times negative 2? Negative 1. 1/2 times 0 is 0. 1/2 times 2 is 1, and 1/2 times 4 is 2. So that formula or equation worked for all of my points. So y equals 1/2 x. I do not have to write plus 0. That doesn't really change anything. So that's my equation. That was a little bit easier. Okay? So put your ordered pairs. Always start where x is 0, and whatever y is what you're adding or subtracting. And then you just kind of have to work backwards to fill in the multiplication part. Okay? All right, you're going to do your 4-9 worksheet, and let me know what you need.